Hello students. So welcome to the video solution of day 4 questions of network theory. So in these three questions I have collected a set of very lengthy kind of questions because I have seen students try to solve very small and short questions in network theory, and they are actually skipping the lengthy questions. And in previous year gates we have seen that sometimes very lengthy questions are coming, and if you have a good practice of solving lengthy questions, then you will be able to score 2-3 extra marks in your gate exam. So that's the motive of these big questions, so that you are prepared for any kind of situation. Okay, so let's begin here with the question number 1. So we have to find the resistance RAB, there is a resistance seen between these two terminals. So first of all, let me draw the circuit between AB terminals. Okay, so I'm not we have to find the current also. So current is simply 120 volts divided by the resistance that we are finding. Okay, okay, so this is the circuit. Now we can see that there is no parallel or series combination, but this 5, 10, and 20 ohm resistances form a Y network. Okay, 5, 10, and 20 form a Y network. Okay, so this is the Y network as we can see here: 5, 10, and 20. Okay, now this Y network has to be converted into a triangular network. Okay, that is Y to triangle, or we can say star to delta. Okay, now I will explain you how to learn the formula, because many a times we used to forgot the formula how to convert this. Okay, so this method will help you in learning the formula. Okay, so we have to convert this purple network into a red network as we can see here. Okay, now let us say this is C, this is D, this is E. Okay, so this is C, this is D, and this is E. Now the method to learn the formula is, whenever we are converting from star to delta, then actually the delta network has resistances connected between the two terminals. As we can see, C and D, this resistance is connected. For example, RCD, this is the resistance. Okay, now the value of RCD is equal to the resistances to which it is connected. Okay, it is connected to 5 and 10. The sum of resistances to which it is connected plus product of resistances to which it is connected divided by the resistance which is opposite to it. Okay, so this is the method of learning the formula. Okay, and you will get the value is 15 plus 2.5. Okay, that is 17.5. Okay, now if we go to this RCE, so RCE will be equal to the value of resistances. So let me change the color. So value of resistances to which it is connected, that is 5 and 20. 5 plus 20 plus product of resistances to which it is connected, that is 5 into 20 divided by the resistance which is opposite, that is 10. Okay, so the value here is 35. Okay, and the third resistance, that is uh, let me take this. Okay, that is RDE. So RDE resistance is equals to the sum of resistances to which it is connected, that is 10 and 20. So 10 plus 20 plus 10 multiplied by 20 divided by the resistance which is opposite, that is 5. So it is 30 plus 200 divided by 5, that is 40. So that is come out to be 70. Okay, so RDA is 70, RCE is 35, and RCD is 17.5. Okay, so this question I have kept especially to just tell you how to learn the method to convert from star to delta, and I will keep one more question to learn how to convert from delta to star. Okay, so now if we redraw the above circuit, then we can see that 12.5, 15, this is 30. Okay, the resistance here will be RCD. Okay, so RCD resistance is 17.5. The resistance here is RCE, which is 35, and the resistance here is RDE, because this is D, this is C, this is E, this is 70. Okay, so here we can see that this combination is 30 parallel 70. Okay, so 30 parallel 70 is 30 into 70 divided by 30 plus 70, that is 21. This is the parallel combination of 12.5 and 17.5. This is the parallel combination of 15 and 35. So between terminals A and B, we will see this kind of figure. Okay, so this is 17.5, this is 35, this is 15, and this is 12.5, and here the resistance is 21. Okay, now 17.5 parallel 12.5 can be easily calculated. Okay, it will come out to be 7.29, and 15 parallel 35 will come out to be 10.5. So the resultant is 7.29, 10.5, 21. Okay, now it is easy that RAB is equal to 21 parallel 7.29 plus 10.5, that is 21 parallel 17.7 something, and it is approximately equals to 9.62 ohms. Okay, so we have resistance RAB, that is 9.62 ohms. Now we have to find the current I. Okay, so current I is equals to 120 divided by 9.62, that will come out to be 12.458 amperes. Okay, so this is the solution to this question. I have tried to explain you how to learn this formula, because many a time students used to forgot this formula. So this is the method. Okay, now let's move on to the next question. So such kind of question will never come in GATE exam. They will not ask you that use mesh analysis to find the current I naught. They will just say that find out the current I naught in the given question. Okay, so that means that you can apply nodal analysis, you can apply mesh analysis, you can apply the combination of both. Okay, so I have given this question to explain you that we can apply the combination of mesh analysis and nodal analysis to solve any of the question. Okay, so let's begin with the question. Okay, so let us draw the circuit. Let us draw the circuit first. So 24, 10. Okay, so we will not follow this I1, I2 or anything else. We will just keep this I naught in the question. Okay, because we do not need to solve for I1, I2 and all. We just need to find the value of I naught. Okay, and we will and I just wanted to wanted to keep this question just to tell you that we will apply, and it is very beneficial to apply the combination of mesh analysis and nodal analysis for solving the question. So let us see that how to solve this question. Okay, so let us assume that current capital I is flowing here. Okay, so I naught will go in this resistance, as we know that. So current in this loop or in this direction will be I minus I naught. So I have applied KCL at this node, that is incoming current is capital I, outgoing current is I naught. So current in this branch will be capital I minus I naught. Okay, now capital I minus I naught is current coming here. Let us say another current small I flows in this branch from 4 ohm resistance. So the current in this branch will be capital I minus I naught minus small I by applying KCL at the node, and thus in this branch the current will be I naught plus I. Okay, and the current in this branch will be capital I minus I naught minus I, and thus the current will go back. Okay, I current will go back. Okay, so this is the circuit that I have drawn. I will just copy this figure and take it to another page. Okay, now let us say this is node A, this is node B, this is C, this is D, this is E, this is F, this is G. Okay, so yeah, I'm making extra nodes because G and F node are same. So just for clarity, I'm just making them because there is no issue. Now there are 3 variables here: capital I naught, and small I. So I need 3 equations to solve it. Okay. So the first equation. So since I have applied KCL at all the nodes, now the 3 equations will be given by KVL. So I will apply KVL in the loops. So let the loop is G A B D G. So this is my first loop. Okay, so G to A, then B, then D, then G. Okay, so now as we can see that from G to A, I am entering this battery from minus terminal. So I will write minus 24 in the KVL. From B to D, from B to D, this is plus to minus because current is I naught current is flowing from top to bottom. So I am entering from positive terminal. So I will put a plus sign, and the voltage is 10 I naught. From D to G, again plus minus 12 is the resistance, and the current is I naught plus I is equals to 0. Okay, so the equation is 22 I naught plus 12I is equals to 24. So this is my first equation. Okay, now let me take black color. Okay, second loop for second equation. So I can have any other loop also. So let us say the loop which will give me a simple equation is F to G, G to A to B, B to C, and then F. Okay, so the outermost loop F to G, G to A to B, B to C, and C to F. Okay, now F to G is 0. G to A, we can see that since I am again entering at the minus terminal, so it is minus 24. A to B, it is 0. B to C, it is again 0. Now C to E, first of all. There will be C to E, then E to F. Okay. Now C to E, I can see that it is plus minus because current is flowing from top to bottom. So it is 24 multiplied by capital I minus I naught. Okay, and then from E to F, as we can see that we are entering from the positive terminal here. So it is plus 4 I naught is equals to 0. So the second equation is 24 is equals to 24 capital I minus 24 I naught plus 4 I naught. So the equation is 24I minus 20I naught is equals to 24. Okay, so this is the second equation. Now we have to write the third equation also, one more equation. So let us take this loop d to g. So let me copy the figure again. I think I have the figure. So this was D terminal, this is E, this is F, and this is G. So the third loop is D to G, G to F, F to E, and E to D. Okay. Now D to G, we can see that since I'm entering from the positive terminal, current is going from top to bottom. So plus is at the top. So plus 12 into I naught plus I. F to G is G to F is 0. F to E we are entering from minus terminal, so it is minus 4 I naught. Now E to D it is plus minus because current is going from right to left, so plus 4 I is equals to 0. So this will give me 12 I naught plus 12 I minus 4 I naught plus 4 I is equals to 0. So 8 I naught is equals to minus 16I. So from here I can see that I naught is equals to minus 2I. If this is the third equation. Okay. So let me collect all the equations. The first equation is 22 I naught plus 12I equals to 22 I naught plus 12I is equals to 24. I think this was the equation. 22 I naught plus 12I equals to 24. The second equation is 24I capital I minus 20I I naught equals to 24, and the third equation is I equals to minus I naught by 2. Okay, now using the third equation I can easily solve the question. Okay, because I only need I naught in the to solve the question. I don't need other values. So I equals to minus I naught by 2. So from third and first equation I can see that 22 I naught plus 12 minus I naught by 2 is equals to 24. 22 I naught minus 6 I naught equals to 24. I naught is equal to 24 divided by 16. That will come out to be 6 divided by 4. That is 1.5 amperes. Okay, so we can see that if we try to solve with mesh analysis, then this question will become very lengthy, because there we will be finding I1, I2 and I3, and I1, I2, I3 will have all the terms in all the equations. So if you are first of all applying KCL in the whole circuit and then applying KVL to solve the equations, then it will be more beneficial, much better than solving the circuit by individually mesh analysis or individually nodal analysis. You have already seen, if you have tried this question by mesh analysis, you would have taken more than 2 pages. Okay, but here I have solved this very easily, because only first equation and the third equation have given me the question directly. Okay, so always try to solve the questions like this only. First apply KCL, distribute the currents, and then apply KVL and solve the question. Okay, so again this question, use mesh analysis to determine the currents I1, I2 and I3. So we will not apply only mesh analysis, we will follow that we used to follow. Okay, that I have already shown you. Okay, so first of all let me draw the circuit. Okay, and always try to choose the loop that will give you the simplest kind of equation. Okay, in mesh analysis we are bound to keep the equations to a limited loop only, but in a simple scenario, when we are finding the only KVL equations, then we can go to any of the loop. Okay, not restricted to mesh. Okay, so this is 2. Okay, so here again we will just cancel I1, I2 and I3. Okay, we know we have to find I1, I2, I3, but we will solve the circuit as we used to solve. That is, capital I current is flowing from the battery. Okay, let us say I small I current is going in in this direction. So here the current will be capital I minus small I. Okay, now since 3 ampere current is going in this direction, 3 ampere current is going here. Okay, capital I minus small I is coming from the top. So the current in this branch, by applying KCL, we can see that it will be, so I will write it here. Okay, so the current will be 3 minus capital I plus small I. Okay, okay, by applying KCL at this node. So how we are getting this current? So let us say that, the current here is I4. Okay, so I4 plus capital I minus I is equals to 3. Incoming current equals to outgoing current. So we can say that I4 equals to 3 minus capital I plus small I. Okay, so like this we can get that. So 3 minus capital I plus small I is a current here. So I'm just rubbing it. Okay, now small I current is coming here. 3 minus capital I plus I is going here. So we can say that the current that will go in this 8 ohm resistance is I8. Now apply KCL at this node B. So the incoming current is I, outgoing current is I8, and the outgoing current is 3 minus capital I plus small I. So we can say that I8 will be equal to capital I minus 3. Okay, so again I will remove all this. Okay, so I'm just applying KCL, and this is capital I minus 3. So this is current I. Now we can easily see that by applying KCL and then applying KVL, we have reduced one variable. In this solution, we will have only two variables, that is capital I and small I. But if we go through by mesh analysis, we have three variables to solve, and the question will become very lengthy. And it is very difficult to solve the question correctly. Okay, it's very difficult to solve the question correctly with the three variables. It is very easy to solve with two variables. Okay, so here are only two variables. I only need two equations to solve the question. That is a very big benefit of this method. So this is node A, B, C, D. Let me say this is E, this is F, okay, and this is G. Okay, so I've just drawn some extra nodes here because B, C, D nodes are same. So just for simplicity, I'm doing it. Okay, now uh, let me apply a KVL loop. So first KVL loop is, I only need two equations here. First KVL loop is A, B, C, D, F, G, A. Okay, so outermost loop. Okay, so A to B, we can see that I'm entering at the negative terminal. So minus 6 volts or minus 6. B to C it is 0. C to D it is 0. D to F it is, since current is top to bottom, so plus is at the top, minus is at the bottom. So I'm entering at the plus terminal. So 2I. Now F to G it is plus at the top, minus at the bottom, because current is flowing from top to bottom. So it is plus 8 capital I minus 3 is equals to 0. So here we can see that it is 2I plus 8 is equals to, sorry, 2i plus 8 capital I is equals to 6 plus 24, that is 30. This is equation number 1. Now second loop, so let us say let us find which is the smallest loop which we can get. Okay, so the only loop left is C D F E. Okay, so we'll solve it. uh, so I'll let us copy the figure. Okay, so the second loop is C D F E C. Okay, now C to D it is 0, D to F we can see we are entering from the positive terminal, so it is 2 into I. F to E, it is plus to minus, current is flowing from right to left and we are also moving from right to left, so we are entering the positive terminal, so it is plus. The resistance value is 4. Yes, the resistance value is 4, right? So it is 4 into 3 minus capital I plus small I. And from E to C, since the current is from top to bottom, so it is plus at the top, minus at the bottom, and we are moving from E to C, so we are entering from the negative terminal, so it is a minus sign to capital I minus small I is equals to 0. Okay, so let's solve this equation. We will get 2i plus 12 minus 4i plus 4i minus 2i plus 2i is equals to 0. So this will give me 4 2 to 8 small I minus 6 capital I is equals to minus 12, or 6i minus 8 small I is equals to 12. So this is equation number 2. So let me write both the equations together. So equation number 1 is 2i plus 8i equals to 30. And the second equation is 6i minus 8i is equals to 12. Okay, so let us divide this equation, second equation, by 4. We will get 6 by 4i minus 2i is equals to 3. This is the third equation. Now subtract these two equations, or sorry, add these two equations. We will get 8 8i plus 1.5 1.5i is equals to 33. Capital I is equals to 33 divided by 9.5, and that will come out to be, so we can see that the answer is 33 divided by 9.5, it will be 3.473. And we can also see that small I is equal to, by solving, let us put equation, the value of capital I in equation number 2. So we can see that in equation number 2 we have 6i minus 8i is equals to 12. 6 into 33 divided by 9.5 minus 12 is equals to 8i, and this is 6 multiplied by 3.47 minus 12 divided by 8. So this is small I is equals to 1.10 amperes, and capital I is equals to 3.437 amperes. Okay, now let us copy the figure. Okay, so as we know, this the current here is capital I. So the current here was capital I, that is 3.474. And if we compare with the figure given in the question, is I1 is a current which is flowing in this loop. Okay, so I1 is a current which is flowing, and 6 volt is a element in this mesh which is exclusively in this mesh only. So the current through 6 volts is equals to I1, and we can see that the current capital I is flowing in through the 6 volt battery. So I1 is equal to 3.474. Okay, the first thing. Second, as we know that the current here is small I, okay, as we have taken that, and small I is equals to 1.10, we have solved it. Now 2 ohm resistance is exclusively in this mesh, so the current through 2 ohm resistance is equals to I3, and I is flowing through 2 ohm resistance, so I3 is equal to 1.10, okay, amperes. Now I2 is a current which is exclusively flowing in this 8 ohm resistance. Okay, so if we find the current through 8 ohm resistance, and we have seen that that is equals to capital I minus 3, so capital I minus 3 will become I2, so I2 is equals to 0.474. Okay, so like this we have solved the question, and this kind of question we have seen in the previous year gate questions of network theory. They are expected questions of gate, you cannot skip them. Just try to adopt a method which will help you in solving such questions in a very smart and very time efficient manner. So adopt this method, it will help you in solving gate questions. So we'll be continuing solving the network questions on next week also. So thank you students, keep sharing these lectures, give us the feedback. Thank you.